In this video, we'll be doing the proof of integration by parts. So the proof is actually simple compared to our chain rule and product rule proof, because this proof stems from the product rule. So the product rule, as we know, we're going to define a function big F of x equals little f of x times g of x. And then we know that the product rule says that d, the derivative of big F of x, equals f prime x, g of x, plus g prime x, small f of x, right? So now what we're going to do is we're going to multiply each side by the infinitesimal dx and dx. Notice that they cancel out. They cancel out over here. So we can get rid of those and we can just erase them here. So we're left with d f of x, and I'll write that down here. So we're left with df essentially, and then over here we have that dx. So now we can go ahead and take the integral both sides. So I'm going to give myself some room for this integral. So taking the integral of both sides, now integral of just df is just f of x, and that's going to equal, if we split up this integral, we get integral of f prime x, and let's write this f prime x as df dx, and gx, and then distribute the dx, plus integral of dg dx times f of x times dx. And notice we have the dx on the bottom and the dx on the top, so those infinitesimals will cancel just like this. And then we have this dx over here, this dx over here. So we're left with g of x, df times g of x. So we're going to put that at the end. dg. So, and that's essentially what the chain rule is, because a lot of books have, they define u equals f of x and v equals g of x. So if we do that, then we have g is going to be replaced with v, and f is going to be replaced with u, and we have f as u, and we have dg as dv. And then if we get rid of all this stuff on the top and bottom, and then we just rewrite it, so we have, and I'm going to write f of x in its true form, so f of x, g of x, and let's write uv instead, so u, v, minus integral of v, du, equals u integral dv. And that is our integration by parts that we all know and love.